Hi, CP Math 1, this is Mr. Roberts, and this is a quick look at the Chapter 1 study team test. Question 1 asks us to consider this particular function, so you can see it, and the first question asks us to describe the domain of that function. So remember, the domain it's a collection of all the x values that produce outputs. So if I just look at the x-axis, starting here at -3 and going all the way until +3, all of those x values that I've highlighted in red produce outputs. So for example, you can see when I plug in x is -3, the equation gives me y is -1. If I plug in x is 0, it gives me y is about +1. If I was to say x is 1, you can see y is somewhere between 1 and 2. So all of those x values produce outputs. So we say that the domain of this function, right, are all of the x values from -3 to +3. And you can write it two different ways. The top thing I've said, x is in this range. X values are greater than -3 but less than +3. And you can just write it out in words, all x values from -3 to 3. The next question asks us to describe the range of this function. And if you look at it, the smallest value that I can possibly get out of this function is the number -1, right? There's no y value that's smaller than that. And this continues, all of these y values work until I get to the largest one. The largest y value I can get is +3. So this thing that I've highlighted in yellow is the range of values that are possible. The range were all those values from y equals -1 up until y equals +3. So again, you can write it this way. The top thing says all y's that are greater than -1 but less than 3, and in words, just all y values from -1 up to +3. Next question, is this a function? Remember, in order for a relationship to be a function, it has to be consistent and predictable. And as I look at the graph of this function, I can see that every single x value is pointing to only one y value. For example, if I was to plug in x equals 3, I can see every single time it'll consistently and reliably tell me that y is 3. So every single time x is 3, y is 3. All of the values are consistent and predictable. No value, for example, x is 1, it's only pointing at this value, right? This particular y value. It's not pointing to any other y value. So this is most definitely a function, and the reason why I can tell is you could say it a couple ways. Many of you said each input value produced only one output. Another thing you can say is that each input consistently and predictably produces the same output. So you can see I've said, yes, this is a function. Each input produced only one output value, values, only one output value, V-A-L-U-E. And it is consistent and it is predictable. And then finally it asks us to approximate what do we get when we place x is 2 into the function. So you can see if I'm placing the value x is 2 into this function, right, I'm just following up until I hit my curve. And you can see right there, it's just past the number 2. So if you were to say about 2, that's good. It looks like maybe it's about 2.1 or 2.2. So you could say it's approximately 2 or 2.1 or 2.2 are probably closer values. And it's kind of difficult to tell just from this graph. The next question says, Peyton solved the following equation. Solve the following equation showing all of his steps. Sadie, a member of his group, thinks that there is an error. Who's correct? Explain how you know. If Sadie is correct, then explain Peyton's mistake and make changes to solve the problem correctly. Well, I think one of the things I like to do is just consider the possibility that Peyton is correct, and I'm going to check that. If Peyton's answer is correct, it has to be the case that when I plug his value in, y is 4, it has to make the left and right hand side of this equation truly equal. So you can see I'm just going to go ahead and place the number 4 in wherever the y's were, -2. On the other side I've got 4 plus 2 times his value of y, which was 4. and then minus 4. So over on the left-hand side, when I consider the 4 plus 1, that's 5. And when I double it, I get 10, and I subtract 2 from that, I can see that the left-hand side is the number 8. So on one side, the left-hand side, I have the value 8. On the right-hand side, I can combine this positive 4 and negative 4 and make a 0. And I'm left with 2 times 4 then, which is on the right-hand side an 8. So because this value 4 is making the left and the right-hand side both 8, it truly is a solution. Now, it's possible he could have made a mistake somewhere, and maybe he made 2 mistakes that cancel each other out. When I look at his work, the first thing I like to see is that he did correctly distribute. So I've got a 2y and a 2, and then a minus 2. When I combine the 2 and negative 2, that's gone. So I'm left with only the y. Next, you can see I just recopied the 4 and the y. From each side of this, then, Peyton's showing that he's subtracting a y. And I don't know that we often do it on the same line like this, but he's showing that he's taking away a y from both sides, which is certainly valid, right? If you can clearly subtract the same thing from both sides. When he does that, he ends up getting, well, he's kind of missing a step here. I guess you would get 2y on one side and equals 4 plus y on the other. And then, oh no, he would, that would be gone. I'm sorry. It's right here, right? This does make a 0, so he's left with a 4. And over here, when you take your 2y and you subtract a y, you're left with a single y. So I'm sorry. It follows quite nicely. I would say definitely that Peyton is correct. So I've just written down here, Peyton is correct. Y equals 4 is definitely a solution. And the important idea here is y equals 4 a solution because it makes the both sides of this equation equal to 8. So y is 4 is a solution, and we can pretty clearly follow his work.